A spring is attached to the ceiling and is pulled 19 centimeters from equilibrium and released. All right, let's stop there for a minute. Let's start to draw a picture. So here's our ceiling right here. The spring is hanging down from the ceiling, and imagine there's a handle or something at the end of the spring, and here's the equilibrium. So you can draw a little dashed line for equilibrium. Okay, so someone comes along and pulls down the spring downward, so it stretches the spring out, and that distance is 19 centimeters. Okay, let's keep reading. It says the amplitude decreases by 13% each second. All right, the spring oscillates 18 times each second. Find an equation for the distance, which we call d, the end of the spring, the distance that the end of the spring is below equilibrium in terms of seconds t. All right, so first of all, we will define down to be positive here in this situation. And so if you make a graph out of this, this is time t, this is distance. So we're starting at 19 centimeters from equilibrium. And then you can see the spring is just going to bounce up and down. It's going to go like this, and it's decreasing 13% every second. And so every time the spring bounces back, comes back a little bit less than before. And so it'll look something like this. All right, now the basic formula, so first of all, it's cosine because it's starting up at the top there. So the basic formula is amplitude times cosine of b times t. We'll just assume the midline is equilibrium, which we'll just call 0. So there's no need for the plus c out there. And there's no phase shift because we're just starting at time 0. So there's your basic formula. Let's call this d right there. All right. Let's start with amplitude first. So the amplitude normally would just be 19. However, the amplitude decreases 13%. So we have exponential decay here. So if you want to make a little table, at time 0, the amplitude is 19. 1 second later, the amplitude is 13% less. So the easiest way to do percent decrease, think of it like this: 13% decrease. Think of it like 100% minus 13%, which is 87%. So in other words, the amplitude is 87% of the original amplitude. In decimal form, that's 0.87. And so in other words, you take your 19, you times by 0.87, and that gives you whatever that gives you. And that's your new amplitude 1 second later. And then 2 seconds later, it's going to be 19 times another 0.87, so it's 0.87 to the second power, and so on and so on and so forth. And so at time t, the amplitude is 19 times 0.87 to the t power. All right, I guess I could, instead of calling that distance, let's call that amplitude right there. Okay, so there's your formula for amplitude right there. All right, now for B. So we're told period. Actually, we're not told period. We're told that the spring oscillates 18 times each second. So that actually is called frequency. So the frequency is 18. We can call it cycles per second. However, for the formula, B is information about period, not frequency. And so period is the reciprocal. So period is the reciprocal of frequency. So that would be 1/18 seconds per cycle. So in other words, for the spring to go down and up one full cycle, it takes 1/18 of a second because it does 18 of those cycles in a full second. All right. And we also know that period is also equal to 2 pi divided by b. All right, so we have a little equation. 1/18 equals 2 pi over b. Just cross multiply here. 2 times pi times 18 is 36 pi. and 1 times b is b. So there's our b. So back to our formula right here. Let's put this all together. So I've got a times cosine b times t. So a was 19 times 0.87 to the t power times cosine of b, which we just solved, 36 pi. So 36 pi times t. Okay, and that equals d. Okay, there is our answer. Let's type this in to the into here. So make sure we've got it right here. So I've got it says distance equals, so I don't have to write the equal sign, I just have to write the equation. So it's 19, let me zoom this in a little bit here. 19 times, that's asterisk, 0.87. You can use parentheses, you can leave the parentheses out actually. And then exponents to the t power, and then times cosine, and then it was 36 times pi times t. Closing parentheses. Okay, let's submit. Okay, we got it right. All right, that's it.